Okay, here we go. What's that noise? You hear that? Who's that? Is that some background song? Oh, perfect. Oh, that's okay. Okay, so hypothesis testing for proportions. So a few things to remember. The population proportion P, just like the population mean is mu, the population proportion is P. The sample proportion is P hat. That's what you found from your data. Now we say we must check the following. We did this in chapter 6, where n times p has to be greater than or equal to 5, and n times q has to be greater than or equal than 5. That's more for stats 2. Okay, when we get more into the depth of statistics. So what's that? The formula? It is a little messy. I didn't write it, but one of the subs did or something. So that is the p hat minus p. It's on page 407. So we have p hat minus p divided by the square root of pq over n. So I know it looks like a d hat minus d, but it's p hat minus p. All over square root of pq over n. Now the key thing with this formula is your p hat. What the heck? Yeah. P hat is a fraction. Leave it as a fraction for accuracy purposes. If you have something like, I know it's small, like 3/6, and you want to make that 0.5, that's fine. Okay, if it's a terminating decimal, that's fine. But usually we're going to run into decimals that are non-terminating, non-repeating, so we just want to use the fraction, so we're very accurate. Okay. This is the same thing, proportion. It's the same as what we did with the mean of large samples and the mean of small samples. Pretty much the same process. What differs is your step 2, and 3 is your formula. And step 4, we have 2 choices. So verify NP greater than or equal to 5, NQ greater than or equal to 5. Again, that's a formality. We are not going to do that every single time. Okay, that's why it's step 0. It's kind of like, don't worry about it. Yeah, but if you happen to take stats 2, or you take stats in college next year, you'd be like, oh, I remember that. Maybe. So state the claim mathematically and verbally, got it. Null and alternate hypothesis. Step 2, level of significance. Key thing is remember to Z critical value again, a Z critical value, not a T. Rejection regions, make sure you determine the rejection regions. And you shade, remember, always shade away from the center. And then your standardized test statistic. P hat minus P all over square root PQ over N. Right, you're making a decision. So with your decision to reject or fail to reject, this step has to be prior, right? This step here, these are my step 4s. So my p-value step, remember the p-value was from 7, 2. You have to use p-value in 7, 2. In 7, 3, you have to use rejection region. In 7, 4, you choose, unless I specifically tell you what to do. You choose either one. Don't put both. You can do both to check. That's good. Okay. And then, of course, refer back to the box sheet. What page was that? Page 9? Was that page 9? Okay. Okay. And did I erase these? Yes, I did. So here's our first example. So the Research Center claims that less than 20% of internet users in the U.S. have wireless network in their home. Random sample of 100 adults, 50% say they have a wireless network in their home at level of significance. So this is my level of significance here. Okay, instead of an A, because whatever, so there's your level of significance. Is there enough evidence to support the researcher's claim? So this is just the way they ask you to do your 5-step process. Now, do you see anything at all with mean or standard deviation? No, it doesn't say anything about mean or standard deviation. So then you see this right here. Okay, that is your p-value. All right, that's your p, and that's going to be your claim. So do not use mu. So in step 1, identify the claim. So here again, the claim is less than. So p is less than 0.20. All other values are greater than or equal to 0.20. So p is less than is your claim. So then identify your null and alternate hypothesis. So you have your null and alternate hypothesis. And again, p, the equals has to go up top. Less than 0.2, that's your claim. That's your alternate hypothesis. And like I said, the first couple steps are, been over and over. I was grading some of them, and some people still don't get what's going on with step 2. So, I don't know, look at your notes, and the notes are right there. So I don't know why, but you look at the what to determine if it's a left tail, right tail, two tail. What do you look at? HA. Okay, so is this a left tail or a right tail? Left tail. That's a left tail. Like I said, 90% you have it. And this is what, 0.01. That's my level of significance. So this is a Z critical value, not a T. There's no degree of freedom. So when I look up 0.01 in the back of the book, I get negative 2.33. Step 2. So then step 3. So you already have P is 0.20. So if you look at your formula, you also need a P hat, a Q, right? Because you look at your formula, and an N. Because my Z, P hat minus P all over square root of PQ all over N. So just identify what you need. You have the P, which is 0.2. Therefore, what is Q? What is Q? 0.8. Because P plus Q has to be 1. Now, P hat, be very careful. Remember, P hat is what you observed. So they gave us to us, bless you, as a percentage. See how they gave it as a percentage? So my P hat is 0.15. You do not have to use a fraction because they gave you an exact percent. And then what's my N? 100. N is 100. Any questions on where any of those values came from? So then plug it in and use your calculator. Put it in your calculator if you have it. I know some of those juniors stole them. So you should get negative 1.25. That's what you get for your Z value. Now you guys got to be careful with this. My Z values go 2 decimal places. How many decimal places does the T go? 3. Okay? Some people only went 2 on the graded assignments. I underlined it. Come test time, you're losing points. Because all this stuff should be right in your notes. There's really no reason to not have one of the steps correct or not know what I'm looking for. So step 4, you have one of 2 methods. So the first one is the p-value method. My p-value method, which we use in 7.2. And you can use here in 7.4 if you like it. So the p-value method, we look up negative 1.25. We get 0.1056. We compare it to 0.01. Because it's a one-tail test, you don't have to double anything. This is greater than. So it's either greater than or less than or equal to. That's the p-value. Step 4. Or, I don't want both of them. You can if you want, but if you do one right, one wrong, I got to take points off. Or you tell me that negative 1.25, and some of you guys are doing this, which is very nice, falls right about there, because this is 0. Now, I'm not going to get so picky. Some people also did, like if this is negative, they put the way over here, or they made this too big. It's okay. Okay, as long as you have it in the rejection region or out. So this does not fall in the rejection region. So it doesn't fall in the rejection region. And the p-value is greater than the level of significance. So we fail to reject the null hypothesis. Again, something you just look up. There is not enough evidence to support the claim. Okay? Pretty much the same thing we've been doing, right? So what is the confusion? The confusion will be here in step 1 to make sure that you have the p or the mu. And then step 2, do I need a z or a t? Step 3, use the right formula. And then step 4, make sure you use the right test, either the p-value or the rejection region. Okay, make sure you use the proper one for each section. Okay. All right, a little research center. The Pew Research Center, more than 30% of U.S. adults regularly watch the Weather Channel. We decided to test this claim, a sample of 75 adults, whether they regularly watch the Weather Channel. Of the 75, 27 responded yes. Again, here's your level of significance. Is there enough evidence to support the claim? Doesn't say anything about mean or standard deviation. So you know you're using a P. Claims that more than, so we have more than, less than, or equal to. Okay, show that somewhere. I can't stand when people do step 1 wrong because they don't show that little bit. So then you have your null and alternate hypothesis. They're both P, less than or equal to, and this is greater than, what is it, 0.3, 0.3. Was the other one 0.3 as well? 0.2. It's all the same level of significance. That's what it was. 2. Okay, right tail test. Same level of significance as the other one, except now we're on the positive side. So just make sure that this is a positive 2.33, not a negative 2.33. And when you get down to putting into your formula, p hat is 27 over 75. Put that in your calculator quick. 27 divided by 75, decimal, enter. What do you get? Wait, what? Does it stop? No, it keeps going on and on, right? If it was just 0.36, fine. We can use it. Okay? But since this is non-terminating, just going on and on and on and on, we want to make sure in our formula we use 27 over 25 minus 0.3 all over the square root of 0.3 times 0.7 all over 75, right? Okay, so this is a little tricky to plug in. It's not supposed to be 75, right? That is a 7. It look like a 2? Okay. You might not be floating right then. Does it? All right, let me take a look. Hold on, let me take a look. All right, so that's good. So you can. Where are you? All right, so you can use 0.36 because it does terminate. You are correct. So 0.36 minus 0.3. Yeah, I'm recording, I think. Yes, I am. So then this is 1.13. Does it fall in the rejection region? No. Does not fall in rejection region. So fail to reject. The null hypothesis. Not enough evidence to support the claim. Okay. Not enough evidence to support the claim. So that's a does not fall in the rejection region one. The last one we do, example 3, we are going to do a p-value. Okay, just so we can have a little review on the p-value. So why don't you see if you can get up to step 3, and then we'll do step 4 together. So you got to be real careful with these now, because they're going to be worth more and more as we keep going. Two-tailed test. 2.575 minus 2.75. Some people didn't have plus or minus 2.575. You lost points. Sorry. Okay, it's a two-tailed test. You have to account for both of them. P hat is 0.08. What's on 250? 2.18? Yes? 2.18. So we are using p-value. So like I said, the previous one is your rejection region. This one's a p-value. So my p-value, cumulative area. My cumulative area is 0.9854. Okay? You get 2.18? All right, everyone's good, right? 2.18? Okay. All right, so you got that p-value. Now, what do I have to do with that p-value? 1 minus. So I have to do 1 minus 0.9854 equals 0.0146. So there's two things that I'm reviewing about p-values in this example. So the first thing is you have to take it away from 1. Because remember, you always shade away from the center. And then because it's a two-tailed test, what do I have to do? Multiply it by 2 because of the two-tailed test. So then I get 0.0292 and compare it to the level of significance. It is greater than 0.01. And that's another one that's right in the book. I don't or right in your notes. Is that page 13? Is that one, or was that the rejection region one? Yeah, page 13. Okay, where you have your inequality symbols. And then from there it tells you what to do in step 5. And since it's greater than, we failed to reject the null hypothesis. There is not enough evidence to reject the claim. Okay, there's a nice little example too. All right, so tomorrow we'll do practice Friday, if you're ready for the quiz, you take the quiz. Monday, Tuesday, we review. Wednesday's a test or Thursday's a test. Doesn't matter, as long as everything's done by Friday. Because I got to get all this in before the end of the third quarter. And then the week before break, we'll do something else. No.